Okay, let's try to do this example correctly this time. Starting over, I'm going to, first of all, think about it on the side in a thought bubble. So this stuff over here is not your solution. It's just kind of me thinking about it. So I say to myself, okay, when n is large, that 1 on the bottom does not matter. So I expect this thing to behave like this when n is large. And summation 1 over n squared is convergent because p is 2, and that's bigger than 1. So I expect my series to be convergent as well. Okay, so this is me deciding what to compare to. So I got my sum and 1 over n squared plus 1. What is the relationship between this and 1 over n squared? Well, on the left-hand side, the denominator is bigger. Okay, so I get that inequality. So I'm dividing by more on the right. So in black on the left here is my solution. So I write down this inequality, which is easy enough to see. To be careful, as you saw, I made a mistake in my video. It's easy to make a mistake. You just have the thing going the wrong way. So double check these inequalities, triple check these inequalities before you hand in your paper. So now I'm using comparison test. So just continuing my sentence here. And summation 1 over n squared is convergent because p is bigger than 1. So summation 1 over n squared plus 1 is convergent by comparison test. And that's all. Okay, so here's my question up here, and below I have, basically you can read this as a sentence in English. Okay, 1 over n squared plus 1 is less than 1 over n squared, and summation 1 over n squared is convergent. So summation 1 over n squared plus 1 is convergent by comparison test. Okay, so that's how you should be trying to write your solutions, as something that I can read from top to bottom.